Hello, welcome to Snowball SH Extra. This is Snowball SH, and we're going to make a simple calculator that can support the strings and just normal the math expression you will write on your math homework. And we will be using something called a parser. And I'm here to teach you how to do some basic parsing. So first, let me put up the whiteboard. Let me explain what is parsing. So here we have a plus b times c minus d. So as our math teacher taught us, for this expression we must combine them with b and c first. This is an more high precedence expression. We need to calculate b, c first. Then from left to right we need to calculate a plus b times c and then minus d. So this is what our math would be like. But if you don't use parsing, your program will never know how to combine these terms. Maybe they will combine like this. So how to teach the program how to uh, bound them the correct way? So like this. So we can define something called precedence or precedence, if you want to say that, for each of the operators. So we can define plus because it has a lower precedence than the star expression or times multiply. So we can define it like this. Plus minus equals 1 and 2. We'll explain why there are two numbers. So as you can see, multiply and divide are greater than plus and minus because we want to group them, stick them together. Now, so first, start and end, we make them 0. So it always be the lowest. And for each operator, on the left, we write the first number. On the right, we write the second number. So for add, we write 1 and 2. For star, we write 3 and 4, and 1 and 2. So basically, what our program will do is that, so there's a pointer. So it will first point to the A and its number, so pass to the operator. The operator is now plus. What is the left operand? It's 1, and its right precedence is 2. So the Pratt parsing is, so whenever the right operator is smaller than the left operator, we stop, okay? We stop. So 2 is greater than 1, no problem. Let's go to star. 3 is greater than 2. It's greater than the previous operation, so we group the right ones together, if you understand. Hope you understand here. So 3 is greater than 2, so we group these ones together. So we basically draw a parentheses here and parentheses here. So everything in the right will be grouped together, but we don't know where to end. Next, we see minus. So minus, we see 1. 1 is actually smaller than 4. Because 1 is smaller than 4, we cannot like move forward. Oh, sorry. Yeah, 1 is smaller than 4. Wrong sign. So because 4 is greater than 1, we cannot move forward. So we must stop here. So here we make another parenthesis to group the forward together. Now we have a plus b times c. B times c grouped together. And now because we only have this is closed and 2 and 1 is normal and it's the same as so this is 2, this is 1, 2 is greater than 1. So we ignore this because we already finish this, so we can ignore this. 2 is greater than 1. Therefore, we need to stop at a plus b times c here. So we put a parenthesis here. Now at last, we see 2 greater than 0. So we put an ending parenthesis. Now this is how our parsing works. Basically, I can explain one more time from scratch. So whenever I see, for example, the right is A, the left is A, the right is B. So whenever A is greater than B, we stop. So for this, 0 is smaller than 1. So we keep forward. We draw a parenthesis here. So we move the pointer to the star, and 3 is still smaller than 4. So we keep moving forward. Now we see minus 4 is greater than 1. So we have this. 4 is greater than 1. Therefore, we need to stop here. We add this here because it's less than sign. So if we see a greater than, we add a right parenthesis. If we see a smaller sign, we add a left parenthesis. So now it is grouped together. Now, because it's grouped together, we need to ignore these two. Okay, we need to ignore those. And so 2 is greater than 1. Therefore, we need to put another parenthesis here because 2 is greater than 1. And finally, to the end, we see 2 is greater than 0, so we add an end parenthesis. Now, this is how it works. So basically, it's just for every less than, you add a left parenthesis. For every greater than, you add a right parenthesis. If you understand this, you are very great. Now let's get into the code. So first, we need to define the precedence or precedence. So add, we define it as 1, 2, minus 1, 2, star 3, 4, and divide sign 3, 4. Now we need to define the token types. So we can say integer equals integer, operator equals operator. It's kind of just divides those token types differently. Now let's write a simple tokenize function. So tokenize is basically telling the programs that a number is a number and a operator is an operator. For example, 1, 2, 3 will not be something like 1, 2, 3. It will be like 1, 2, 3. It will group the numbers together. So if you can see, we said while if it is still valid and the current character is digit, and we add this to this variable, and finally we make it into an integer. So we keep looking for if the next character is an integer. If it's an integer, we group them together. We add to the v, which is a string, and if we see the last is end of file or space, we can keep going and group this as an integer. And now for other characters, if the current character is inside is one of plus, minus, star, and division, and we can just say it's an operator. So let me explain this code. So we got a text string where we want our math expression. So we have result. We will return something like a list of tuple of token type, these two, and a token value, anything. So while while this is valid, so text index of I, this is the current character, and this basically handles the integer, and this handles the operator, else we just pass. For example, new line, space, or other characters. You can have some time to code this out. Now, after coding it out, we need to do the parser. But before the parser, we need to something to iterate through our token, and we need to next and peak. So we define a simple helper class called iterator. You can basically copy this code if you don't know object-oriented programming. For the initialize, we accept a value of list and we set the value to value. Next, we try to return the popped first value. If the length is only 0, we return EOF. End of file is defined here. EOF stands for end of file. For peak, it's similar. We return the first item of self.value, and if it's not valid, we return end of file. You can copy this code. Every code will be in the description. For the calculate history, we still have this code, the same code. This is all the same code, except we need to add a functions. This is the function we will handle in our evaluator. So for plus sign, we plus, minus sign, we minus. So this is basically what to do. Tokenized function is the exactly same. Iterator is the exactly same. Now we have a very important parse function. So this is what we are talking about in this whiteboard. So we have a tokens of iterator, this one, and precedence and integer, any of those. For our first start of program or end of program, this will be 0. So first, we need to get the first token, this one, for example, A. In this case, a math expression is probably 1, 2, 3. If it's not an integer, we will say syntax error, so it's not a valid expression because we don't want to something like uh, this one. It's not valid. Now, so while true means recursively or loop, make a loop that keeps detect if the next expression is smaller than the precedence you will see now. This is the operator type, operator value. Operator type means if it's an operator or an end of file or an integer. So if it's an end of file, we break. If it's not operator, for example, it's integer, I will raise another syntax error because we don't want something like 1, 2, 3, 4 with no operator in the middle. Next, we need to find the precedence of the current operator. So left means the left precedence, right means the right precedence. If this is the most important thing, so if left is smaller than the precedence given here, for example, 3 is smaller than 2, it's not valid, and if 1 is smaller than 4, it's valid. So in this case, we need to add a right parentheses. So this is basically add a right parentheses. Break is basically terminating this parse and add a right parentheses. And if it's not smaller than, we make a next. So we skip this peak. And for the right, we see this right for, so a plus b times c. So b times c is not a terminator, so we keep for looking for the right operator. Sorry, right number. So right, we need to recursively parse the right one. So this the recursion starts, and the same tokens. It's a point. It's basically a pointer to the value, so every function can access it. And right, so it's basically this. So in the parse function, for example, reached here, we need to, at first our argument is 0. Now our argument is 2. So we start the b times c parsing with the 2 here. So now it's our parsing time. And after the parsing, we have a right and left. Of course, so the functions like the a plus b, and left and the right. So what we are returning here is, so we define x as a tuple of a function and many arguments. For example, now it's 2, or integer. If you can understand here, you're very great. We use x here because we're recursively looking for this. So this would be a node, and this node can be another this node. And we return the left. We can show the algorithm here. So at the start, we called parse some tokens 0 because this is 0. Now we look for if the operator, we skip the a, so we detect the a, and we find plus. So 2 is not smaller than 3. Sorry, 1 is not smaller than 0, 0. 1 is greater than 0, so we don't terminate. If 1 is smaller than 0, we need to add in, parentheses here. So we skip this to the b, and now we start this code. So this is not true, so we don't do anything, and we next, and we parse again. So for this, we do parse something 2, because this is 2. This 2, and from the parsing, we find b. And find star. Star is 3 and 4. So we look for if 3 is smaller than 2. It's not, so we keep forward. We keep to C, and we find minus. Minus is 1 and 2. 1 is smaller than 4. Therefore, we need to add in right parentheses here and terminate this parse. Now we went back. The result of this is currently finished. So b times c, and we return back to the a plus. Now from the plus, because we stopped here and the part left, we now continue to the next token. So it's minus. Because we already parsed this, so we can just cross this, and it's 1 and 2. 1 is smaller than 2. Therefore, we stop here too. We add another right parentheses. And now we start over here. And here we need to have the last operator. And 2 is greater than 0, so no terminator, and D. And now we combine them together as A plus B times C minus D, the correct way. If you understand this code, you are a genius. Actually, almost nobody can understand this. I hope I explain well. Okay, so for calculator 4, the version 4, it's all the same, all the same, all the same, except we have an execute function. Execute accept some nodes, and the nodes is like this. If the node is an integer, we just return the node, else. So nodes is a function followed by some argument. We call the function, and the arguments are execute every single the arguments. It's very understandable. So if we change this to something like 1 plus 2 times 3 should be 2 times 3 equals 6 plus 1, 7. Look, 7. So it's very working. So if we delete 3, it will erase error. Expecting number got none. Now here's the problem. So we don't have support for our parentheses in our max expression. This is kind of an extra or bonus episode or function. It's 4.0, but actually it's calculated 2 times 3 divided by 2 and 1.1 plus 3. What we want is 1 plus 2 times 3 equals 6. 1 plus 6, 7 divided by 2, 3.5. Now the last step is to add support for parentheses. So everything is the same except for the tokenizer. Sorry, for the token types, we have an parentheses, extra parentheses defined here. Also, if this is in left or right parentheses, we say the token type is parent and the current character. Now in parsing, this is important stuff. So in this, if we move this to an elif, if left type is parent and it's left parentheses, we don't want to be like something like weird, like 1 this plus 3 like this. It's not valid. So if it's left parentheses, we just skip everything and just parse it. Just ignore it and parse it. And if finished is not a right parentheses, we raise an error. So we don't want like something like parentheses 3 plus 4 and no right parentheses. And so we don't want to break after we hit in parentheses because we don't want to ignore the parentheses and go forward or raise an error. So in the loop, we say if operator type is ELF or parentheses, we break. So if parentheses, we break too. And we got here and finish. So if you run this, we can see the result is 3.5 because it's grouped this together. Now there's something I have forgotten, so we can view what each of the files do. So for calculator 1, we can say print tokenize, for example 1 plus 2 times 3. If we run this, we will see integer 1 operator plus integer 2 operator times integer 3. Now it's basically, if we make it larger, it is the integer 124, integer 245435. Now for calculator 2, we don't need it to show anything because it's just an iterator. And for calculator 3, this is the basic parsing. We can say print parse tokenize, actually iterator tokenize 1 plus 3 times 3 and 0. 0 is our second argument. We can also say this is equal to 0 But let's do this. So we'll see some lambda and 1 and some and parentheses, some lambda 2, 3. This is because we are adding. This is add function. This is 1. This is the right operand grouped times 2 and 3. This is basically adding 1 and 2 times 3. Now this is the finished code, and I will put it on in the description where you can all view and download. I hope you enjoyed this video, and if it explained well, feel free to leave a comment or a like, and see you next time.